Human body is amazing. In next 45 minutes, we will go through the amazing body system. This video includes 9 chapters and will teach you the most important aspects of your body. Like the video and share it with your loved ones if you enjoyed it. Let's dive in.
1 hour with human body. Introduction. The human body, nature's masterpiece. The human body is nothing short of a biological marvel. Composed of trillions of cells, it operates with incredible precision and efficiency, allowing us to live, move, think, and feel. Beneath our skin lies a network of interconnected systems, each performing specific functions that are essential for survival. From the rhythmic beat of the heart to the rapid firing of neurons, every process is carefully orchestrated, reflecting the sophistication of natural design. At its core, the body is made up of several major systems. The nervous system, the master controller of thoughts, sensations, and movement. The cardiovascular system, delivering life-sustaining oxygen and nutrients. The respiratory system, enabling the exchange of gases to keep our cells alive. The digestive system, transforming food into energy and building blocks for growth. The musculoskeletal system, providing structure, support, and the power to move. The immune system, defending us against unseen threats. The lymphatic system, cleaning up waste and supporting immunity. These systems work together in perfect harmony, adapting to our needs, healing when damaged, and defending us from external threats. Understanding how each of these systems functions not only deepens our appreciation for the complexity of life, but also empowers us to take better care of our health. In the chapters that follow, we will explore each of these systems in detail, unraveling the secrets behind their operations and discovering how they contribute to the miracle that is the human body. Chapter 1. The Nervous System, Command Center. The human body operates with an astonishing level of precision and synchronization, and at the heart of this remarkable machinery is the nervous system. Often referred to as the body's command center, it is responsible for controlling and coordinating every action, sensation, and thought. Composed of the central nervous system, CNS, and the peripheral nervous system, PNS, its primary role is to transmit signals between different parts of the body, enabling everything from simple reflexes to complex cognitive functions. The central nervous system, CNS, the control hub. The CNS consists of 2 main components, the brain and the spinal cord. The brain, weighing about 1.4 kilograms, is the most complex organ in the human body. It houses approximately 86 billion neurons, the cells that transmit electrical impulses. Each neuron can connect to thousands of others, forming intricate networks that process information and send commands. The brain is divided into several regions, each responsible for different tasks. The cerebrum manages higher functions such as thought, memory, and voluntary movement. The cerebellum, located at the back of the skull, is essential for balance and coordination. Meanwhile, the brainstem handles automatic functions like breathing, heartbeat, and digestion. Directly linked to the brain, the spinal cord acts as a communication superhighway. Extending from the brainstem down the spine, it carries signals between the brain and the rest of the body. This structure is also responsible for reflex actions, which are rapid responses to stimuli that occur without conscious thought. For example, if you touch something hot, the spinal cord sends a quick signal to your hand to pull away even before your brain registers the pain. The peripheral nervous system, PNS, the communication network. While the CNS serves as the control center, the peripheral nervous system is the vast network that connects the brain and spinal cord to every other part of the body. It is divided into 2 major systems, the somatic nervous system and the autonomic nervous system. The somatic nervous system controls voluntary movements and transmits sensory information. It allows you to move your arms, walk, speak, and respond to your environment. If you decide to pick up a glass of water, it's your somatic system that sends the necessary signals to your muscles. On the other hand, the autonomic nervous system manages involuntary processes like heart rate, digestion, and respiratory rate. It operates silently in the background, regulating bodily functions without conscious effort. This system is further divided into the sympathetic and parasympathetic nervous systems. The sympathetic nervous system triggers the fight-or-flight response during moments of stress, increasing heart rate and adrenaline. Conversely, the parasympathetic nervous system helps to calm the body down, slowing heart rate and promoting digestion. How signals travel the neuron network. At the core of the nervous system's communication is the neuron. Neurons are specialized cells designed to transmit information through electrical and chemical signals. This process begins when a neuron is stimulated by an external factor, such as touch or sound. The neuron generates an electrical impulse that travels down its axon until it reaches the synapse, a small gap separating it from the next neuron. At the synapse, the electrical signal triggers the release of neurotransmitters, chemical messengers that carry the signal across the gap to the receiving neuron. This continuous chain of communication enables you to react to your surroundings in real time. For instance, if you hear a loud noise, your sensory neurons detect the sound and send signals to your brain, which then processes the information and prompts a reaction, like turning your head or jumping in surprise. The nervous system's brilliance lies in its ability to process information at incredible speeds, often faster than you can blink. This intricate network not only keeps you aware of your surroundings, but also maintains your body's internal stability, ensuring that you breathe, your heart beats, and your muscles move, all without conscious thought. Chapter 2. The Cardiovascular System, the Lifeline. The human body relies on a constant supply of oxygen and nutrients to function, and the cardiovascular system serves as the crucial lifeline that delivers these essential elements to every cell. Often described as the body's transportation network, this system includes the heart, blood vessels, and blood itself. Together, they form an intricate circuit that not only nourishes tissues, but also carries away waste products, maintains temperature balance, and supports the immune response. The heart, nature's perfect pump. At the center of the cardiovascular system is the heart, a powerful muscular organ roughly the size of your fist. Situated slightly to the left of your chest, the heart is divided into 4 chambers: the right atrium, right ventricle, left atrium, and left ventricle. These chambers work in unison to pump blood throughout the body. The heart operates in 2 primary phases: systole. During this phase, the ventricles contract, pushing oxygen-rich blood out of the heart and into the arteries. Diastole. In this phase, the heart relaxes, allowing the chambers to refill with blood. The rhythmic contraction and relaxation create your heartbeat, which is crucial for maintaining circulation. On average, the heart beats 100,000 times per day, pumping about 5 liters of blood per minute, a testament to its efficiency and endurance. Blood vessels, highways of life. Blood travels through an expansive network of blood vessels, categorized into 3 main types. Arteries. These vessels carry oxygen-rich blood away from the heart to tissues and organs. The largest artery, the aorta, is the main highway, branching out into smaller arteries and eventually reaching even the tiniest cells. Capillaries. These are the smallest blood vessels where the actual exchange of oxygen, nutrients, and waste occurs. Their walls are only 1 cell thick, allowing for efficient transfer of materials. Veins. Once blood has delivered oxygen and nutrients, it returns to the heart through veins. Veins are equipped with tiny valves that prevent backflow, ensuring that blood flows in the right direction, even against gravity. This continuous loop is known as systemic circulation, where oxygenated blood is delivered and deoxygenated blood is returned for reoxygenation. Blood, the life force fluid. Blood is far more than just a red liquid. It is a living tissue composed of multiple components. Red blood cells, RBCs. These are responsible for carrying oxygen from the lungs to body tissues and returning carbon dioxide back to the lungs for exhalation. Hemoglobin, the protein inside RBCs, binds oxygen and gives blood its red color. White blood cells, WBCs. These cells are warriors of the immune system, defending the body against infections and foreign invaders. Platelets, critical for blood clotting. Platelets prevent excessive bleeding when injuries occur. Plasma, making up about 55% of blood. Plasma is a yellowish liquid that transports hormones, nutrients, and waste products. Each drop of blood carries around 5 million red blood cells, reflecting the system's efficiency in oxygen transportation. How the cardiovascular system maintains life. The cardiovascular system's brilliance lies in its synchronization. When you exercise, your muscles demand more oxygen, prompting your heart to pump faster and harder. Simultaneously, your blood vessels adjust to direct more blood to the areas that need it most. In contrast, when you rest, the system conserves energy, maintaining only the essential functions. Moreover, the cardiovascular system plays a crucial role in thermoregulation, the process of maintaining body temperature. Blood vessels expand to release heat when you are too warm and constrict to conserve heat when you are cold. A perfectly timed rhythm. The heart's rhythm is orchestrated by an electrical signaling system. The sinoatrial SA node, known as the natural pacemaker, sends out impulses that trigger heartbeats. This electrical activity spreads across the heart's chambers, ensuring that they contract and relax in perfect unison. Any disruption to this rhythm can lead to arrhythmias, which can affect blood flow and overall health. The cardiovascular system is truly a marvel of biological engineering, continuously working, adapting, and responding to the body's needs without pause. Its unyielding rhythm keeps life flowing, minute by minute, heartbeat by heartbeat. Chapter 3. The Respiratory System. Breath of life. Breathing is so automatic that we often take it for granted. Yet with each breath, a remarkable process unfolds within our bodies, sustaining life and fueling every cell. The respiratory system is responsible for this critical function, delivering oxygen to the bloodstream while expelling carbon dioxide, a waste product of cellular metabolism. This exchange of gases occurs seamlessly, ensuring that the body remains balanced and energized. The anatomy of the respiratory system. The respiratory system consists of two main sections, the upper respiratory tract and the lower respiratory tract. Upper respiratory tract, nose and nasal cavity. The journey begins as air enters through the nose, where it is filtered, warmed, and humidified. Tiny hairs called cilia trap dust and pollutants, preventing them from reaching the lungs. Pharynx, throat. Air moves from the nasal cavity into the pharynx, a muscular passage that serves both the respiratory and digestive systems. Larynx, voice box. Next, air passes through the larynx, which not only channels it towards the lungs, but also enables speech through vocal cord vibrations. Lower respiratory tract, trachea, windpipe. A sturdy tube reinforced with cartilage rings that directs air from the larynx to the lungs. Bronchi and bronchioles. The trachea splits into two main bronchi, one for each lung. These bronchi branch into smaller bronchioles, resembling the limbs of a tree. Alveoli. At the end of each bronchiole are tiny air sacs called alveoli. This is where the critical exchange of gases takes place. The lungs contain about 600 million alveoli, providing a massive surface area for efficient gas exchange. The process of breathing. Breathing or ventilation consists of two main processes, inhalation and exhalation. Inhalation, inspiration. When you breathe in, your diaphragm, a dome-shaped muscle located below the lungs, contracts and moves downward. At the same time, your intercostal muscles between the ribs expand the chest cavity. This creates negative pressure, drawing air into the lungs. Exhalation, expiration. Exhaling is typically a passive process. The diaphragm relaxes, moving back to its dome shape, while the intercostal muscles allow the chest cavity to contract. This forces carbon dioxide-rich air out of the lungs. This rhythmic cycle happens about 12 to 20 times per minute for adults, amounting to roughly 20,000 breaths per day. During physical exertion, the rate increases to meet the body's heightened oxygen demand. Gas exchange, the breath of life. The true magic of the respiratory system happens at the alveoli. Each alveolus is surrounded by tiny blood vessels called capillaries. When you inhale, oxygen fills the alveoli and diffuses through their thin walls into the capillaries, where it binds to hemoglobin and red blood cells. At the same time, carbon dioxide, a byproduct of cellular processes, moves from the blood into the alveoli. This carbon dioxide is then expelled from the body during exhalation. This continuous cycle ensures that every cell receives the oxygen it needs to function while removing harmful waste products. The respiratory system in health. The respiratory system is incredibly efficient, but it is also vulnerable. Factors such as pollution, smoking, and infections can impair its function. Chronic conditions like asthma, chronic obstructive pulmonary disease, COPD, and lung cancer can severely disrupt gas exchange, leading to serious health issues. The body has protective mechanisms to keep the airways clear. For example, mucus in the respiratory tract traps dust and microbes, while cilia sweep the mucus upwards, allowing it to be coughed out or swallowed. When this system is overwhelmed by pollutants or disease, breathing becomes labored and oxygen delivery is compromised. The importance of healthy breathing. Maintaining respiratory health is crucial for overall well-being. Regular exercise, avoiding pollutants, and not smoking are vital steps to keeping the lungs healthy. Simple breathing exercises can also strengthen the diaphragm and improve lung capacity, enhancing the efficiency of oxygen exchange. Every breath you take is a testament to the respiratory system's elegance and efficiency. It delivers the air that keeps you alive, one breath at a time, day and night, awake or asleep. Chapter 4. The Digestive System, Fueling the Machine. Every time you eat, you set into motion one of the most intricate processes in the human body: digestion. The digestive system is responsible for breaking down the food you consume, extracting nutrients, and converting them into energy to power every cell in your body. This system also handles the removal of waste, ensuring that what isn't needed is efficiently discarded. The entire process is a perfect blend of mechanical and chemical activities, designed to extract the maximum benefit from everything you consume. The anatomy of the digestive system. The digestive process begins the moment food enters your mouth and continues through a series of well-coordinated steps involving multiple organs of mouth, oral cavity. Digestion starts in the mouth, where food is chewed and mixed with saliva. Saliva contains enzymes like amylase, which begins the breakdown of starches. The teeth crush and grind food, turning it into a soft mass called bolus. Your tongue then pushes the bolus to the back of the throat for swallowing. Pharynx and esophagus. After being swallowed, the bolus travels down the pharynx, throat, and enters the esophagus. This muscular tube uses wave-like contractions, known as peristalsis, to move food toward the stomach. A valve called the lower esophageal sphincter prevents backflow, ensuring that food does not re-enter the esophagus. Stomach. The stomach is a muscular, hollow organ that acts as a powerful blender. It secretes gastric juices, including hydrochloric acid, HCl, and pepsin, which further break down food, especially proteins. The stomach's churning motion helps mix food with these enzymes, turning it into a semi-liquid substance called chyme. Small intestine. Chyme then enters the small intestine, which is the primary site for nutrient absorption. This long coiled tube is divided into 3 sections. Duodenum. The first part, where digestive enzymes from the pancreas and bile from the liver are released. These substances help to digest fats, proteins, and carbohydrates. Jejunum. The middle section, where most nutrient absorption occurs. Ileum. The final section, which absorbs vitamins and remaining nutrients. The inner walls of the small intestine are lined with villi, tiny finger-like projections that increase surface area for absorption. Nutrients pass through these villi into the bloodstream, where they are carried to cells throughout the body. Liver, gallbladder, and pancreas. These organs play supporting roles in digestion. Liver produces bile, which helps break down fats. It also processes nutrients and detoxifies harmful substances. Gallbladder stores bile and releases it into the small intestine when needed. Pancreas produces digestive enzymes and insulin to regulate blood sugar. The large intestine, waste processing and water absorption. After nutrients are absorbed, the remaining indigestible food passes into the large intestine. Here, water and electrolytes are absorbed, and the leftover material is compacted into feces. The large intestine includes cecum, the starting point where waste enters from the small intestine. Colon absorbs water and forms solid waste. Rectum stores feces before they are expelled. Friendly bacteria in the large intestine also help break down some materials and produce vitamins like vitamin K and biotin. The role of digestive enzymes. The efficiency of digestion depends heavily on enzymes, which are biological catalysts that speed up chemical reactions. Each type of nutrient, proteins, fats, and carbohydrates requires specific enzymes. Protease breaks down proteins into amino acids. Lipase splits fats into fatty acids and glycerol. Amylase converts starches into sugars. These enzymes work together harmoniously to ensure that nutrients are extracted quickly and efficiently. The final step, elimination. Once water is reabsorbed and waste is compacted, the final stage is elimination. Waste is expelled from the body through the anus during defecation. This process ensures that toxins and unneeded materials do not remain in the body, contributing to overall health and balance. Maintaining a healthy digestive system. The digestive system is remarkably resilient, but still benefits from proper care. Balanced diet. High-fiber foods help keep things moving, while lean proteins and healthy fats aid in smooth digestion. Hydration. Water is crucial for digestion and helps prevent constipation. Exercise. Regular physical activity promotes good bowel movement. Avoiding excessive stress. Chronic stress can disrupt digestive health, leading to conditions like irritable bowel syndrome, IBS. The digestive system is a masterpiece of engineering, working tirelessly to convert what we eat into energy and essential building blocks for life. It is not merely a process. It's a symphony of biological harmony that ensures every cell in your body is nourished and energized. Chapter 5. The Musculoskeletal System, Structure and Movement. Movement is one of the most fundamental aspects of human life, allowing us to walk, run, lift, and interact with the world. Behind this seemingly effortless ability lies the musculoskeletal system, a complex network of bones, muscles, tendons, ligaments, and joints. It is this system that provides structure to the body, protects vital organs, and enables both fine and powerful movements with astonishing precision. The anatomy of the musculoskeletal system. The musculoskeletal system is composed of two major components: the skeletal system, the rigid framework that supports and shapes the body; the muscular system, the dynamic force that moves the skeleton. 1. The skeletal system, the body's framework. The human skeleton is made up of 206 bones, varying in size and shape, each with a unique purpose. These bones are classified into different categories. Long bones, found in the arms and legs, such as the femur and humerus. They are crucial for large movements and supporting weight. Short bones, small and cube-shaped. Like those in the wrist and ankle, these bones provide stability and some movement. Flat bones, thin and curved, such as the skull, ribs, and sternum. They protect vital organs and provide surfaces for muscle attachment. Irregular bones, complex shapes like the vertebrae and pelvis, supporting the body and protecting the spinal cord. The skeleton serves several vital functions. Protection, shields organs like the brain, heart, and lungs. Support, maintains body structure and posture. Movement, provides leverage for muscles to pull on. Mineral storage, stores calcium and phosphorus, crucial for bone strength. Blood cell production, houses bone marrow, which produces red and white blood cells. 2. The muscular system, powering movement. While the skeleton provides the framework, it is the muscles that generate movement. The body contains over 600 muscles, classified into 3 main types. Skeletal muscles. These are the muscles attached to bones by tendons. They are voluntary, meaning you can control them, like when you decide to lift your arm or walk. Smooth muscles, found in the walls of internal organs such as the stomach, intestines, and blood vessels. These muscles work involuntarily, moving food through the digestive system and regulating blood flow. Cardiac muscle. This unique muscle is found only in the heart. It contracts rhythmically and involuntarily to pump blood throughout the body. How muscles and bones work together. Movement occurs through the cooperation of muscles and bones at the joints. When a muscle contracts, it pulls on the bone it is attached to, creating movement. This process is facilitated by two key types of tissue: tendons, tough fibrous cords that attach muscles to bones; ligaments, bands of connective tissue that connect bones to each other, stabilizing joints. For example, when you bend your arm, the biceps muscle contracts while the triceps muscle relaxes. This pulls the radius and ulna bones of the forearm upward, creating the bending motion. Types of joints: flexibility and range of motion. Joints are where two or more bones meet, allowing for different types of movement. Hinge joints, found in the elbows and knees, allowing movement in one direction. Ball and socket joints, present in the shoulders and hips, enabling movement in multiple directions. Pivot joints allow for rotation, such as turning your head side to side. Gliding joints, found in the wrists and ankles, permitting bones to slide over one another. The smooth movement of joints is assisted by cartilage, a flexible, rubbery tissue that reduces friction and cushions impact. Synovial fluid, a lubricating liquid, also plays a vital role in keeping joints flexible and friction-free. Maintaining the musculoskeletal system. The musculoskeletal system, while strong, is not indestructible. Regular exercise, proper nutrition, and good posture are essential for keeping bones and muscles strong. Important nutrients include calcium and vitamin D, essential for bone density and strength. Protein supports muscle repair and growth. Magnesium and phosphorus aid in bone development and maintenance. Physical activity, particularly weight-bearing exercises, stimulates bone growth and strengthens muscles, reducing the risk of conditions like osteoporosis and arthritis. Stretching and flexibility exercises also help maintain joint health and prevent stiffness. Common disorders of the musculoskeletal system. Like any system, the musculoskeletal framework is prone to injuries and diseases. Fractures, breaks in bones caused by excessive force. Arthritis, inflammation of the joints, leading to pain and stiffness. Osteoporosis, a condition where bones become weak and brittle. Muscle strains, overstretching or tearing of muscle fibers. Tendinitis, inflammation of the tendons due to overuse. Proper care, regular exercise, and a balanced diet are key to maintaining the health and strength of this vital system. The musculoskeletal system is a masterpiece of biological engineering designed to support, protect, and propel the human body. Every movement, no matter how small, is a testament to the intricate collaboration between bones and muscles. Chapter 6. The immune system. The body's defense. Every day, the human body is exposed to countless threats, from viruses and bacteria to harmful toxins. Yet most of the time, we remain healthy and unaffected. This is thanks to the remarkable work of the immune system, a highly sophisticated defense network that detects, fights, and eliminates harmful invaders. It operates silently and tirelessly, protecting you from illness and keeping your body in balance. The structure of the immune system. The immune system is not confined to one location. It is a network of cells, tissues, and organs spread throughout the body. Its main components include white blood cells, leukocytes. These are the primary fighters of the immune system, responsible for identifying and destroying harmful invaders. There are two main types: phagocytes, cells that engulf and digest pathogens; lymphocytes, cells that remember previous invaders and attack them faster if they return. These include T cells and B cells. Lymphatic system. This is the circulatory pathway for immune cells, transporting them to areas of infection or inflammation. It includes lymph nodes, lymph vessels, the spleen, and the thymus. Lymph nodes act as filtration sites, trapping harmful particles and providing a base for white blood cells to destroy them. Bone marrow. This spongy tissue inside bones is where white blood cells are produced and mature. Spleen. The spleen filters blood, removing damaged cells and harmful microorganisms. It also produces white blood cells to combat infections. Thymus. This small organ is where T cells mature. T cells are crucial for attacking infected or cancerous cells. How the immune system works. The immune response is a three-step process that kicks in when a threat is detected. Recognition. The immune system identifies foreign invaders like bacteria, viruses, or parasites as non-self. These invaders are marked by unique molecules on their surfaces called antigens. Attack. Once a threat is recognized, the immune system launches an attack. Phagocytes engulf the invaders, while B cells produce antibodies, special proteins that bind to antigens and neutralize them. T cells target infected cells, destroying them to prevent the spread of infection. Memory formation. After the invader is eliminated, the immune system remembers it. Memory cells are created to recognize the pathogen if it reappears, leading to a faster and stronger response. This is why people often only get diseases like chickenpox once. Types of immunity. The immune system provides two types of protection. Innate immunity. This is the body's first line of defense. It includes physical barriers like the skin, mucous membranes, and stomach acid, as well as immediate responses by white blood cells. Adaptive immunity. This is the body's targeted response to specific threats. It develops over time and becomes stronger with repeated exposure. Vaccinations work by training this part of the immune system to recognize and combat specific pathogens. The role of inflammation. One of the immune system's first reactions to infection or injury is inflammation. It is characterized by redness, swelling, heat, and pain. Although often uncomfortable, inflammation is crucial for healing. Vasodilation. Blood vessels widen to allow more white blood cells to reach the affected area. Increased permeability. More immune cells can move from the bloodstream to the site of infection. Signal to repair. Inflammation triggers cells to begin repairing damaged tissue. However, chronic inflammation, when the immune system remains active for too long, can lead to diseases like arthritis, diabetes, and heart disease. Autoimmune disorders and allergies. Sometimes the immune system mistakenly targets the body's own tissues, leading to autoimmune diseases like lupus, rheumatoid arthritis, and multiple sclerosis. In these cases, the immune system cannot distinguish between self and non-self, attacking healthy cells. Allergies are another form of immune system misfire. They occur when the body responds aggressively to harmless substances like pollen, pet dander, or certain foods. The immune system releases histamines, causing symptoms like sneezing, itching, and swelling. Boosting the immune system. A strong immune system is vital for maintaining health. Here are key strategies to support it. Nutrition. Foods rich in vitamin C, vitamin D, zinc, and antioxidants are known to enhance immune function. Exercise. Regular physical activity promotes healthy circulation, allowing immune cells to travel efficiently. Sleep. During sleep, the body repairs and regenerates cells, including those of the immune system. Hydration. Water helps flush out toxins and maintain the flow of lymphatic fluid. Stress management. Chronic stress suppresses the immune response, making the body more vulnerable to illness. The immune system is a remarkable defense mechanism that protects you from countless potential threats every day. Its ability to remember past invaders and adapt to new ones is a testament to its complexity and efficiency. Every breath you take, every step you make, your immune system is there, guarding, defending, and keeping you alive. Chapter 7. The Lymphatic System, the body's cleanup crew. While often overlooked, the lymphatic system plays a crucial role in maintaining your body's health and balance. Acting as the body's cleanup crew, it works alongside the immune system to filter out toxins, fight infections, and maintain fluid balance. This network of lymph nodes, vessels, and organs ensures that excess fluid is drained from tissues, harmful pathogens are neutralized, and waste products are efficiently removed from the body. The structure of the lymphatic system. The lymphatic system is made up of several key components. Lymph, a clear, watery fluid that circulates through the lymphatic vessels. It carries white blood cells, particularly lymphocytes, which are crucial for fighting infections. Lymph also contains proteins, waste products, and fats absorbed from the digestive system. Lymph vessels. These are thin-walled tubes that run alongside your blood vessels. They collect excess fluid from tissues, which is then filtered and returned to the bloodstream. Unlike blood vessels, lymph vessels do not have a central pump, like the heart. Instead, they rely on muscle contractions and one-way valves to push lymph through the system. Lymph nodes, small bean-shaped structures scattered throughout the body, especially in the neck, armpits, and groin. They act as filtration hubs, trapping bacteria, viruses, and other harmful substances. Inside the nodes, lymphocytes and macrophages attack and destroy these invaders. Organs of the lymphatic system, thymus. Located behind the sternum, it is where T cells mature and learn to differentiate between the body's own cells and foreign invaders. Spleen. The largest lymphatic organ, it filters blood, removing old or damaged blood cells and fighting infections. Tonsils and adenoids. These are the first line of defense against inhaled or ingested pathogens. The functions of the lymphatic system. The lymphatic system performs three primary functions essential for maintaining health. Fluid balance. Approximately 20 liters of plasma flow out of your blood vessels into body tissues each day. While most of this fluid is reabsorbed into the bloodstream, about 3 liters remain in the tissues. The lymphatic system collects this excess fluid, now called lymph, and returns it to the circulatory system, preventing swelling, edema. Immune response. Lymph nodes act as security checkpoints where lymph is filtered. If harmful pathogens like bacteria or viruses are detected, white blood cells are activated to attack and neutralize them. The lymphatic system also helps to distribute antibodies throughout the body. Absorption of fats and fat-soluble vitamins. In the small intestine, specialized lymphatic vessels called lacteals absorb dietary fats and vitamins, A, D, E, K, from digested food. These nutrients are then transported through the lymphatic system before entering the bloodstream. How lymph moves through the body. Unlike the circulatory system, which is powered by the heart, the lymphatic system relies on a different mechanism. Skeletal muscle contractions. As you move, your muscles naturally compress lymphatic vessels, pushing lymph through the system. One-way valves. These valves prevent backflow, ensuring that lymph flows in the right direction, toward the heart. Breathing movements. The act of breathing creates pressure changes in your chest that help propel lymph through its vessels. Common disorders of the lymphatic system. Although efficient, the lymphatic system is not immune to problems. Some common conditions include lymphedema, a condition where lymph fluid builds up in tissues, causing swelling. This often occurs when lymph nodes are removed or damaged during surgery. Infections. Lymph nodes can become swollen and tender during infections such as strep throat or mononucleosis. Lymphoma, a type of cancer that originates in the lymphatic system, affecting the body's ability to fight infections. Filariasis, elephantiasis, a parasitic infection that blocks lymph vessels, leading to extreme swelling in the limbs. Maintaining a healthy lymphatic system. Keeping your lymphatic system in good condition is key to overall health. Here are some effective ways to support its function. Stay hydrated. Lymph fluid is primarily water, so drinking enough water helps maintain its flow. Exercise regularly. Physical activity encourages muscle contractions that help move lymph fluid. Deep breathing. Slow, deep breaths stimulate lymphatic flow through pressure changes in the chest. Massage therapy. Techniques like lymphatic drainage massage can help stimulate the flow of lymph, especially after surgery or injury. Healthy diet. Foods rich in antioxidants, like berries and leafy greens, help cleanse the lymphatic system. The lymphatic system may be silent and often unnoticed, but its contribution to health is profound. It is the body's natural detoxification network, sweeping away waste, filtering pathogens, and ensuring that fluids are in constant balance. Without its diligent work, even the simplest infections could become life-threatening, and the body's tissues would swell uncontrollably. Chapter 8. Conclusion. Harmony and Health. The human body is an extraordinary masterpiece of biological engineering, designed with precision and purpose. From the rapid-fire communication of the nervous system to the life-sustaining rhythm of the cardiovascular system, every organ, cell, and molecule works in seamless harmony. Understanding how these systems interact not only deepens our appreciation for the body's complexity, but also empowers us to maintain its health and vitality. The symphony of systems. Throughout the previous chapters, we explored the major systems that sustain life. The nervous system, commanding every thought, movement, and sensation. Its network of neurons and synapses allows us to perceive and react to the world with incredible speed. The cardiovascular system, the lifeline of the body, circulating oxygen and nutrients while removing waste products. Its unyielding rhythm keeps us alive, heartbeat by heartbeat. The respiratory system, the gateway for oxygen intake and carbon dioxide removal. With each breath, life is renewed and cells are fueled for optimal function. The digestive system, a marvel of mechanical and chemical processing, breaking down food into essential nutrients and eliminating waste. The musculoskeletal system, providing structure, strength, and mobility. It allows us to move, interact, and engage with our environment. The immune system, the vigilant guardian, identifying and neutralizing threats while building long-term defenses. The lymphatic system, the silent cleanup crew, managing fluid balance and filtering out toxins to keep the body in equilibrium. Each of these systems operates both independently and collaboratively, creating a delicate balance that defines good health. When one system falters, others are often affected, showcasing the profound interconnectedness within the human body. The power of balance and maintenance. The secret to maintaining this harmony lies in understanding the needs of each system. Proper nutrition. Every cell depends on nutrients like vitamins, minerals, proteins, and fats. A balanced diet supplies the building blocks for cell repair, energy production, and disease prevention. Regular exercise. Physical activity strengthens muscles, improves cardiovascular efficiency, supports lymphatic drainage, and boosts immune response. Quality sleep. During sleep, the body repairs tissues, consolidates memories, and rejuvenates cells, especially within the nervous and immune systems. Stress management. Chronic stress disrupts hormone balance, weakens the immune system, and accelerates cellular aging. Techniques like meditation, yoga, and mindful breathing can help maintain equilibrium. Hydration. Water is vital for nutrient transportation, waste elimination, and cellular processes. Proper hydration supports the lymphatic system, digestion, and muscle function. Adapting to challenges. The human body is remarkably resilient, capable of adapting to changes and overcoming challenges. Whether it's fighting off infections, recovering from injuries, or managing long-term health conditions, the body continuously strives for homeostasis, a state of internal balance. Understanding how each system works enables us to recognize early signs of imbalance. For example, persistent fatigue could indicate issues with the cardiovascular or respiratory system. Joint pain and stiffness might be signs of musculoskeletal strain or inflammation. Digestive discomfort can reflect dietary imbalances or gastrointestinal health issues. Frequent infections could signal a weakened immune system in need of support. When we listen to these signals, we can take proactive steps to restore balance, often preventing minor issues from escalating into major health problems. A journey of lifelong health. Our bodies are not static. They evolve and change over time. As we age, the needs of each system shift, requiring different forms of care and attention. Maintaining lifelong health is not a single event, but a journey of continuous learning and adaptation. By understanding how the body works, we are better equipped to make informed choices, whether it's the food we eat, the exercises we perform, or the way we manage stress. The more we understand, the more empowered we become to protect and nurture this biological masterpiece we inhabit. Embrace the miracle of the human body. In the end, the human body is a testament to nature's ingenuity, a perfectly synchronized machine that works tirelessly to keep us alive, aware, and engaged with the world. Each heartbeat, every breath, and every movement is a reminder of the complexity and wonder of life itself. Cherish it, protect it, understand it. The better we care for our bodies, the more it will reward us with strength, vitality, and the opportunity to live life to its fullest potential.